Hi guys, how are you? Right. This is just a conclusion of our previous lessons. The few previous lessons that we have had, and we're going to be concluding on complete dominance. Right. Obviously, the very first thing that we do is that we look at our previous lesson. So we're doing monohybrid crosses, and then we did the Mendel crosses, and we're using tall plants. So what did we figure out from our last lesson? We figured out that when you cross two characteristics, when you cross two things for a particular characteristic where both parties are in a heterozygous state. Let me repeat that. We found out from our last lesson that when we cross two individuals for a particular trait, and for those individuals, both of them are exhibiting that trait in heterozygous state. In a heterozygous state, and if they're exhibiting in a heterozygous state, we learned that when you do a cross between two heterozygous characteristics, then we're going to end up with a phenotypic ratio of 3 of the dominant is to 1 of the recessive. And we learned that in the genotypic ratio, we are going to end up with a genotypic ratio. Let me try to blow this up for you. A genotypic ratio of 1 homozygous dominant for that trait is to 2 heterozygous for that state is to 1 homozygous recessive for that trait. Right. So, and then we look at the chances and everything like that. So, because we're using height in pea plants, these conclusions are for height in pea plants where tall is the dominant trait. This same applies for any characteristic that exhibits complete what? Dominance, whereby the dominant allele will mask the recessive allele in the phenotype, and only the dominant trait is the one that will be exhibited in the phenotype. So for any characteristic that exhibits complete dominance, these ratios stand true. And you will find that in exams, you will be asked. We're going to do questions later, but we're going to tackle some questions. Yeah, we're going to. And we'll look at some of these things. So these ratios are something that you should not forget. Right. I hope we got that. So we did the crosses and we did the Punnett square and we did all that. Now, after all this, when all is said and done, what does this mean? This means that, so for this lesson, we're just concluding it. So it's nice and short. A cross between a tall and short pea plant, both in homozygous state, produced only tall offspring in the first generation. If it produced only tall offspring, if they only produced tall offspring, produced only tall offspring in the if it produced only tall offspring, only tall, what happened to the short? We had a cross between a tall and a short pea plant, and both were in homozygous state. And they only produced what? Only tall offspring. This means that tall was completely dominant over short. And because of that, this is an example of what? Complete dominance. So in other words, tall is dominant over short and masks the short trait. Now, in the heterozygous genotype, this is your heterozygous genotype. This one. The blood will appear tall is only the effect of the dominant allele will be expressed in the phenotype. And the effects, now listen to this. Why did I do this conclusion? Because of this. The effect, I hope you guys are writing notes. And you want to you pause or you take screenshots of my screen. And then you write your own notes. Because my notes, the ones that I put on the board, are answers. They're not answers, they're leading to answers. So you need to have them. Right, the effect of the recessive allele is only expressed in the phenotype if the gene pair, in other words the phenotype, is double recessive. The effect of the recessive allele is only expressed in the phenotype. In other words, in simple English, what we're basically saying is this: for you to get a recessive phenotype visibly expressed, the physical appearance, and it is that of the recessive phenotype. That can only happen if the genotype is homozygous recessive. So, the effect of the recessive allele is only expressed if in the phenotype. The effect of the recessive allele is only expressed in the phenotype if the gene pair, sorry, this is supposed to be if the gene pair genotype is double recessive. Right? We're done with that. We sorted. I hope you got that. Let me see. Right. Something I want to talk about. You don't need to know it, but you have to know it. You don't need to know it, but you have to know it. Why? You don't need to know examples of dominant and recessive traits in humans. Let me repeat. You don't have to know them. You don't have to go and claim these characteristics. You don't have to. The only reason why I'm putting them here is for science of life. Just for your curiosity. Listen, I'm passionate about my subject, and I'm hoping that you're here because you're passionate about it, or you want to pass, whichever. Wanting to pass creates the passion. But anyway, now, look at this. These are different characteristics in human beings. And then these are the dominant and the recessive traits of each characteristic. So for example, brown, eye color, brown is dominant over blue, which is the recessive. Now listen to this. The reason why I put this on the board is because of the following. It doesn't mean that if in a population some particular trait appears many more times than the other alternative form, that means that that particular trait is dominant. No. Let me repeat myself. I hope the one that I want is okay. It's not here. Which one would I use? Right. Let's look at cheese. Let me repeat myself. It doesn't mean that if a particular trait appears in a population in large numbers over the alternative form, that means that because the numbers are many, it must be the dominant one. No, it doesn't necessarily mean that. It does not necessarily mean that. Right. Let's look at cheeks. You either have dimpled or normal cheeks. Now, listen to this. I think we can all agree that usually most people don't have dimples. I think that's why other people actually find them to be attractive, because they are unique. But yet dimples are a dominant trait. Dimples are a dominant trait, and yet normal cheeks are the recessive. As a matter of fact, just for your own damn knowledge, for the science of life, for your personal knowledge, you will not be asked this. A lot of the characteristics that you find in a population of human beings are in the recessive form. Why? That guarantees that the majority of the population have the characteristic. If it was in the dominant form, every time when there'll be crosses, you're going to end up with a lot of phenotypes that will allow, if you have it in a heterozygous state, you're going to have offspring, many individuals in a population. If there's a heterozygous state, can you imagine that every time when they are reproducing, can you see how, I'll give you an example, having 5 fingers. Having 5 fingers is a recessive trait. That is why polydactyl, those who have 6, is a dominant trait. If we all have 5, and this is in its recessive what? State. It means that my genotype has got what? Has got a homozygous recessive. For what? For 5 fingers. And that means that if you have 5 fingers naturally, then you also have homozygous recessive what? Homozygous. So I'm only producing one type of allele for number of fingers. The next person is also reproducing what? Is only producing what? Only one type of allele for what? 5 fingers. If the majority of the population are like that, then it means that every time when the population produces, the dominant number of times that the dominant trait that will appear, I said the dominant trait that will appear is 5 fingers. And yet the reality is that having 5 fingers is actually recessive, and having polydactyl, having 6 fingers is actually dominant. I hope you got that. So it doesn't necessarily mean that because the majority of the population have what? 5 fingers, that having 5 fingers is the allele that's dominant. No. No, 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 no. Why am I saying this? Is because we're going to look at questions where examiners will throw you off and will tell you that rabbits in Uncle Jack's farm, there were 2 types of rabbits, and then you automatically assume that the one with more, or if we're talking of fair color, you automatically assume that the one with more fair color, like the number of rabbits that have more of a particular fair color is the dominant trait. It may not necessarily be. I said it may not necessarily be the dominant trait. So we're going to look at those questions later, and you need to remember what I just told you. I hope you enjoyed complete dominance. We are done with complete dominance. So yes, take care.